Swayam Prabha. Digital India. Educated India.
The next part of the question is compute the per capita electricity consumption and per capita primary energy use for Sweden in 2016. This is simple, just divide these numbers and you get, just take the total population divided by the total electricity use kilowatt hour divided by the population, and you get 13,838 kilowatt hour per capita. Primary energy, if we again divide 2048 into 10 raised to 15 by 9.9 into 10 raised to 6, turns out to be 207 gigajoules per capita. Now we can compare it with the primary energy per capita for India and the world, and you can see that the primary energy supply, the per capita for Sweden is greater than that of the world average and greater than that of India, which is as we expected, but we have been able to quantify. So how then the question is, comment on these values, how do these link with development? But typically what happens is that with a higher level of income, you would have a higher requirement of electricity use, and you can see that very clearly that in the Indian context, the energy use and the electricity use is significantly lower than that for Sweden. We have also, the next table shows us the Sweden electricity sector mix in hydro, nuclear, wind and solar, and the generation. So we can see very clearly that in this particular case there is a significant amount of then the total including the thermal, if you look at it, the installed capacity of hydro is quite significant. We can see that hydro and wind together is a significant proportion of the total. So we should then the question asked is, compare the capacity factor of the wind and nuclear plants for Sweden. So this is fairly straightforward because we have the installed capacity and the generation, and all that we need to do is that we need to find out the capacity factor. So in the case of wind, the generation is 15.5 terawatt hours, that is 15.5 into terawatt is 10 raised to 12 watt hours, and if you want to make it in kilowatt hours, this will be 10 raised to 9 kilowatt hours divided by, let's look at the installed capacity of wind. Installed capacity of wind is 6,520 megawatt, which is into 10 raised to 3 kilowatt, and into the total number of hours is 24 into 365 or 8760. This is the maximum generation possible if all the wind capacity is operating continuously at its rated value, right? So this will be also in kilowatt hours. This becomes a factor which is the capacity factor. You can calculate this and you will find that this turns out to be 0.267, 26.7%. It's a fairly high, for wind it's a fairly high capacity. The Indian wind regime capacity factors are much lower, it's like 14-15% on an average, But also remember that this is going to be lower than that which is there for the base load coal or thermal plants. We will also see that it's actually going to be lower than the nuclear. Let's look at the nuclear same way. Let's calculate the nuclear. In the case of nuclear, we are told that it's 60.5. So we can do in the same fashion, and nuclear is 9075. 9075 into 10 raised to 3 into 8760. Calculate this, you find 0.761, 76.1%. We are also asked to compare the capacity factor of this. Obviously, capacity factor of nuclear is higher. We expect that it runs at a baseload plant. Wind will the capacity factor is constrained by the supply of the wind. And now we are asked to compare the carbon intensity of Sweden's energy sector with India, and to comment on the emission intensity of Sweden's power sector as compared to India. So, in order to do this, the carbon intensity, let us see. We have the total CO2 emissions, which is given to us as CO2 emissions million tons. Let's take it for 2016. This is 36 million tons, and this is to be divided by the amount of electricity that we are generating. And the total, we are doing it per unit of primary energy. So, by 2048 primary energy, and this is in petajoules. So, this is 10 raised to 15. If we want to do this in terms of kg, we will have a 10 raised to 3 factor, and you will find when you calculate this, this comes out to be 36,000 by 2048. 17.6 kg of CO2 per gigajoule. Okay, let's look at now what were these India numbers. CO2 per primary energy for India and the world are almost the same. Sweden is lower than this, and the reason for this is that if you look at Sweden, there is a significant share of renewables and hydro, and India is predominantly coal based, and with the result that we expect that the emissions intensity of Sweden's power sector is going to be lower than that for India, significantly lower than that of India. The next part of the question is, we was asked to use the using the Kaya identity, comment on the changes in the carbon intensity of energy, the energy intensity of the economy for Sweden during 2010 to 2016, and then compare this energy intensity with energy intensity of India. What does the energy intensity reflect? Does a lower energy intensity imply more energy efficient economy? So, let us look at the Kaya identity. If you look at for Sweden for 2016, the total CO2 emissions is 38. So, this is 38 by 2048. This is CO2 per unit energy into energy per unit GDP, E by GDP into GDP per population into population. And on the next year this becomes 46. This is this is the recent year 2016. In 2010 it was 46, which was 46 by 2132 into 2132 by 391. Let's just check which years it was. Let's see the values. 46 is the 46 is for 2010, and this is for in 2010 we had this as 2132. The purchasing power parity, this was 391, and then this was 391 by 9.3 into 9.3. So, if you look at this first term in 2016, 2010, this turns out to be the number is CO2 kgs. You see, what happens in this case is that we have a decrease in the carbon intensity. 38 by 2048 is less than 46 by 2132. There is a carbon intensity of energy decreases, and this decreases from this decreased by about 14%. The energy use per so there is an overall decrease in the CO2 emissions because the carbon intensity has decreased, as well as the energy intensity of the economy. So that means both these numbers, when you say 38 by 2048 and has decreased, this 38 by 2048 is less than 46 by 2132, this is decreased, and similarly 2048 by 448 is less than 2132 by 391. So both the carbon intensity CO2 per unit of energy has decreased, as well as energy per unit of GDP has decreased. So even though the GDP increased and the population increased, overall the total CO2 emissions has decreased. So this is the situation for Sweden. Then the next part of the question is that comment on the compare the carbon intensity, energy intensity, compare the energy intensity with the energy intensity for India. The energy intensity of Sweden is similar to that of India, but it is less than, if you look at these values, the energy intensity per unit of GDP, if we are looking at that, in the case of India it's about 4.6 megajoules per US dollars, and in the case of Sweden, when we calculated this, we saw that it's almost similar. The next point was that what does the energy intensity reflect? Energy intensity can reflect the efficiency in your system. If you have a more efficient use of energy, then we would have this the energy intensity per unit of output would decrease. But does an lower energy intensity imply a more energy efficient economy? This is not necessarily true, because the energy intensity of the economy also depends on the structure of the economy. Where does the GDP come from? If the economy produces more industrial goods, the energy requirement is higher. If it is more in manufacturing, if you are doing steel, cement, aluminum, we'll need more energy. However, if the the GDP is coming from the services sector, the energy requirements are less. So, lower energy intensity, if the structure of the economy is the same and the GDP is coming from the same sectors, then of course, if you have a lower energy intensity, it means that we have become more efficient. But if the structure has changed, it is possible that a lower energy intensity can be done because we have shifted from manufacturing to services, and even though we haven't improved the efficiency. So, then the last question which is there in the paper is comment on the difference in perspectives and strategies for Sweden and India vis-a-vis the global climate change negotiation. So, the first point which should be kept in mind is that Sweden, when we look at the CO2 per population, it's significantly higher than that of India. It's also it's about 3.83 tons per capita. The income is higher than that of India. So, Sweden would be one of the countries which would be considered as a developed country. It has also now gone to a stage where the energy use per capita is significantly higher than the world average. It has an onus to reduce its energy intensity. It is fortunate that it already has a mix of energy which is less carbon, which is the CO2 per unit of energy is lower than that of the of India or of the world average, and the negotiation strategy for Sweden would be where it is trying to actually stabilize, and it is already contributing more to the it's in one of those countries which has already utilized a reasonable part of the of its CO2 budget. India, on the other hand, is a developing country where the all the different components, the infrastructure is not yet in place, and we still need significant increase in the basic energy services. Sweden may have almost saturated in terms of energy services. So, in a sense, we are approaching the problem from different perspectives. India wants to have space to grow and try to grow that sustainably, which is reflected in our Paris commitments. Sweden, on the other hand, could take a stance that we would like to try and minimize, but it would try to, it is already one of the countries which is one of the on a per capita basis a higher emitter. It would like to negotiate for emission targets based on per GDP rather than per capita. India would like to negotiate based on a per capita basis. However, having said that, Sweden is actually one of the countries which has been pushing for higher renewables and strategies which will reduce and mitigate climate change. Sweden has also made ambitious targets, and as you saw over the years in this time period 2010 to 2016, the overall CO2 emissions have actually declined. So, from the Paris Agreement point of view, different countries could have different perspectives based on what is their status and what is their expected growth. So, with this we complete the solution of this paper. You may want to just look at how you have performed, and then if you have any questions, please feel free to mail those to us.